The following promotional film, compiled we believe in 1932, takes us on a unique tour of the Talbot factory. We are shown the front of the building with its portico much the same as it is today. Mr. Robertson, the general manager, is obviously there to guide us through into the factory. This film covers all aspects of the production, including the bodybuilding Darrock works in Acton, through to the finished products ready for dispatch. The design office, where George Roche's design schemes will be converted into hundreds of design drawings, giving the detailed dimensions and material specifications to produce the castings and machine tools to be set up to finish manufacturing them. The vital records of all parts and any changes were kept in this department. Roche was uncompromising in matters of quality control, and as the inspectors on the shop floor would ensure that drawing tolerances were maintained, only Roche himself could make any concessions. Here a simple jig holds this 105 front axle, while the accurate 4-spindle multi-head drills the 4 spring clamping holes in one operation. The axis is turned around for the process to be repeated at the other end. Camshaft grinding is a copying process, whereby the cam form on the large master cam on the right hand side is transferred exactly to the actual 105 camshaft on the left hand side. The operator shows a 75 camshaft where the helical gear that drives the distributor is midway between the widely spaced support bearings. For a high performance car, the underbonnet view of a Talbot is functional rather than glamorous. A little enhancement obtained by polishing the steering box and its pedestal helps. Similarly, polished and plated Rudge Whitworth knock-ons are a necessary piece of bright work for this class of car. The crankshaft is maintained from a solid triangular section forged steel billet in a specialized lathe able to provide rotation about the main center line and then about the 3 big end center lines in turn. The triangular section allows each crank throw to have weights fitted to provide 100% balance of reciprocating forces and hence smooth high-speed running. The 7 main bearings are extremely narrow for 1930 but of large diameter and enabled Roche to produce a remarkably short 6-cylinder engine. The crankshaft grinding machine is used to produce the final very accurate and smooth surface finish ready for fitting with individually machined white metal connecting rods and main bearings. Here we see gear shaping on 18-tooth planet gears for the newly introduced pre-selector gearbox. The gear and reciprocating cutter are rotated whilst being brought into mesh, thus generating the involute tooth form. This 75 block is firmly clamped into its jig, ready for 6-spindle boring machine to cut all 6 cylinder bores simultaneously. The spindle spacing is 93 mm, and Roche determined to maintain this spacing when designing the 105-110 engine for reasons of cost, lead time and factory space. This expensive multi-head drilling unit for simultaneously drilling 23 holes in the sump face of a 75 block. Clearly another similarly expensive unit is necessary for the 105-110 engine. This single spindle bore grinding machine could make 75, 90, 105, 110 cylinder bores simply by changing the cutters and locating jigs. The inspection department are busy checking the new pre-selected gearbox parts. The aluminium casing is undergoing dimension checks on an accurate and flat surface table. The gearbox input shaft on the right is probably having small burrs removed prior to being made up into an assembly with a top gear clone clutch. Process 17 take 1 looks like a well-rehearsed reassembly of a 75 crankshaft into the crankcase. The operator is having some difficulty because the main bearing on the right-hand side near to the helical gear also controls crankshaft end float, has very little clearance and requires precise alignment to allow the crank to fall into position. Notice that the 7590 engine has no crankshaft damper. When it is fitted, however, it consists of two small flywheels frictionally clamped on either side of the flange, seen integral with the helical gear. Here we can see pistons being assembled onto their connecting rods, and the caliper is used to check the straightness of the rod. The remarkably advanced two-piece piston had an aluminium crown and iron skirt united by the gudgeon pin. Tapping the pin into the piston crown is a surprise, as the fit necessary for use ought to be easily assembled by hand. However, assembling the piston onto the connecting rod is more difficult due to the very close fit necessary, and the mallet is required. Similarly, close fit is essential in both the connecting rod and the tiny cotter groove in the gudgeon pin for the small cotter bolt to prevent any movement between pin and rod. A perfectly satisfactory and well-proven system, but only if great precision is maintained. It seems a simple task assembling the piston horizontally into the vertical cylinder block. Again, notice that the small dab of grease was used on the big end bore. The rough cast inlet and exhaust ports are smoothed with a hand grinding wheel to improve the performance on this 105 cylinder head. And this 95 head is pre-assembled with polished inlet, exhaust manifolds and water manifold and carburetor. The famous Talbot needle push rods are easily popped into place, to be followed by the fulcrum and rockers. In the engine test shop, the engines are hand cranked for starting, and the valve clearances are set up with the engine running, a unique feature of Talbot design. It is interesting to note that on this engine the cooling fan is running and will be quite dangerous for the operator, and obviously this is for the purpose of the film only. Here we can see the rockers being adjusted, with the lock nut being undone and then the adjusting screw changed. A view from the front of the engine shows in this case that the fan is stationary, as would be normal practice. The pre-selector gearbox uses a series of simple epicyclic gear trains linked together. Each train consists of a sun wheel in the centre, meshing with 3 planet gears mounted in the carrier, all set inside an internal annulus gear, which is usually the brake drum. The fitter progressively assembles the gear set, starting with reverse, then adding first, second and third gear trains to produce the complete gear set, which he then fits into the gearbox casing. The test shop running included checking out the pre-selector gearbox. The top cover is removed so that each gear can be seen to be engaging, and that pumping the clutch pedal causes the automatic brake band adjuster to set itself to the clamping force dictated by the square-headed stop screws. The tester is double checking the third gear auto adjuster by deliberately unscrewing the adjuster nut a little, refitting the loop spring, and pumping the pedal to observe that the automatic adjustment is taking place. The powerful 400mm diameter self-servo front brake shoes are fitted to the back plate. The two shoes are hinged together, and the brake application applies only the leading shoe, which in turn applies the trailing shoe with much greater effort. And here we can see the camera operated leading shoe being operated. The brake drum is then fitted. The spiral bevel pinion and its support bearing have already been set up with the correct bearing clearances and locked into place in this torque tube. The differential casing is now screwed on, but is not yet fully engaged to allow plenty of room to fit the crown wheel and differential assembly. Having the torque tube clamped firmly in a horizontal position allows the differential assembly to be rotated to enable easy assembly of the side bearings and subsequently their fine adjustment to get the precise clearance for the teeth of the crown wheel and pinion gears. The steering box assembly shows the simple and efficient worm and nut system. The nut sits in a forked arm attached to the drop arm, which follows an arc as the steering wheel and its tube are turned. The fitter here can be seen assembling the internal control levers which operate the choke and throttle before fitting the second half of this housing. These controls are operated from the centre of the steering wheel. The complicated thermostatically controlled radiator shutters are a tricky assembly operation, but our fitter is clearly an expert. He then fits the handsome chromium-plated outer shell. The system works extremely well, preventing overcooling and overheating, just as the designer intended. This trolley-mounted 75 engine and pre-selected gearbox assembly is rolled under the raised front of the chassis, which is then lowered into place. After some persuasion, the engine bolts are fitted. Similarly, the back axle with workshop wheels is rolled into position under the rear end of the chassis. The torque tube is fed over the centre crossmember and into the back of the gearbox, and the spherical housing is bolted into place. A rubber seal ring is fitted into the radiator water boss feed extension of the crankcase, and a similar dummy support for the offside rubber pad fitted. The radiator assembly is then carefully put into place. The front chassis has now been hoisted up to allow the trolley supporting the engine to be removed, and the front axle with its new wheels and tyres can be rolled into place, and the U bolted into position. Magically, we now have a fully dressed rolling chassis, requiring only a small adjustment to the brake pedal position before being fitted with one of the rudimentary test bodies used on all cars. We can see 7 chassis fitted with these bodies, plus some finished cars taking their final road test check. This is the body shop with the adjacent Darrett works, where frames are being made using templates to define the exact shape. The large stock of seasoned ash is kept in the workshop to help stabilise the timber before use. The labour-intensive nature of coach building is well illustrated by the short wheelbase Noel Rees style bodies taking shape in the body shop. The halves of the rear quarter are being smoothed into shape, ready for the padded black fabric covering. The man fitting the boot lid seems to be in a quandary, whilst the front hinges are finally screwed into place. The full extent of the skilled carpentry work is well illustrated in this view. This 6-light long wheelbase saloon is being power disc sanded to take out the blemishes prior to painting. The Squeaks and Rattles department has an unusual test rig on which a finished but untrimmed body is attached whilst a twisting action is applied. The operator has a stethoscope and listens to the flexing joints to detect unacceptable noise. Talbots were very proud of their quality control with regards to Squeaks and Rattles and developed techniques, as we see here, to check that their thick layers of waxed fabric between the panels and the body were being effective. Here we can see steel bonnet sides being prepared ready for painting, and here they are being dropped into a hot degreasing tank and cleaning tank prior to that painting. Here we can see front wings being removed from the tank. The high temperatures are used to help a self-drying situation. The wings are then transferred and lowered onto a rack. Which is then moved into a drying cabinet. For painting, the body is seated on a castered trolley to easily be rotated for spraying the whole body. And here we can see the operator rotating the body to get round to the back. Women are employed to rub down the early coats using power disc mops. It would appear that the finished painted body is raised into a dustproof housing to allow the last coat of paint to harden free from dust. And here we can see it being raised into the box. This also allows the spray painting of the underside to be done for maximum weather protection. Now the hide upholstery is being fitted to the rear seat cushions, whilst another fitter is checking that the large sunshine roof would operate smoothly and easily. Here we can see the completed cars being driven around the test track, which we originally saw in 1905 and still being put to good use in 1932. In fact, it still existed in 1984 when the STD register visited there. Brand new cars are here lined up in front of the factory, waiting for their new owners. Perhaps a small number of minor blemishes being sorted out. Here we can see a member of the sales team greeting his new owner. Paperwork being completed and the car ready for handing over to the new owner. In this case, trade plates have been fitted prior to the car being sent off. Everything seems to be in order. The new owners are departing proudly with their new Talbot.